Welcome back to the Network Plus training series. In this lesson, we are covering Objective 1.8, Summarize Evolving Use Cases for Modern Network Environments. Networks are no longer just about connecting computers in an office. Today's networks must support an ever-growing variety of devices, applications, and environments. This objective focuses on the emerging trends and technologies that are shaping modern networking. Let us begin with the Internet of Things, or IoT. IoT refers to the growing network of physical devices embedded with sensors, software, and connectivity that allows them to collect and exchange data. IoT devices include smart thermostats, security cameras, medical devices, industrial sensors, wearable fitness trackers, and smart home appliances. From a networking perspective, IoT presents unique challenges. IoT devices often have limited processing power and memory, requiring lightweight communication protocols. The sheer number of IoT devices can strain network resources and address space. Many IoT devices have weak or no built-in security, creating potential vulnerabilities. Networks must be segmented to isolate IoT traffic from critical business systems. Next, let us discuss the concept of Bring Your Own Device, or BYOD. BYOD policies allow employees to use their personal devices like smartphones, tablets, and laptops for work purposes. While BYOD can increase productivity and employee satisfaction, it introduces significant challenges for the network. Network administrators must implement mobile device management, or MDM, solutions to enforce security policies. Network access control, or NAC, is used to verify device compliance before granting network access. Separate network segments, often through VLANs, are created for personal devices to isolate them from sensitive corporate resources. Industrial Control Systems, or ICS, and SCADA, which stands for Supervisory Control and Data Acquisition, are systems used to monitor and control industrial processes. These are found in manufacturing plants, power grids, water treatment facilities, and other critical infrastructure. ICS and SCADA systems increasingly rely on IP-based networks, making them potential targets for cyber attacks. Securing these systems requires network segmentation, specialized firewalls, and strict access controls. Voice over IP, or Voice over IP, is the technology that allows voice communications over IP networks instead of traditional phone lines. Voice over IP is now standard in most businesses. From a networking perspective, Voice over IP requires careful quality of service, or QoS, configuration to ensure voice traffic receives priority over less time-sensitive data. Voice over IP is sensitive to latency, jitter, and packet loss, so the network must be designed to minimize these issues. Video conferencing and unified communications have exploded in adoption. These applications combine voice, video, messaging, and collaboration tools into a single platform. Examples include Microsoft Teams, Zoom, and Cisco WebEx. These applications require high bandwidth, low latency, and consistent network performance. Edge computing is an approach where data processing occurs close to where the data is generated, rather than sending everything to a centralized data center or cloud. By processing data at the network edge, organizations reduce latency, minimize bandwidth usage, and improve application performance. Edge computing is particularly important for IoT deployments and applications that require real-time processing. 5G and cellular connectivity are becoming increasingly important for network professionals. 5G networks offer significantly faster speeds, lower latency, and the ability to support many more devices compared to previous generations. This enables new use cases like autonomous vehicles, remote surgery, and massive IoT deployments. For network professionals, understanding how cellular connectivity integrates with traditional wired and wireless networks is essential. Virtual Desktop Infrastructure, or VDI, delivers desktop environments from a centralized server to end-user devices. Instead of running applications locally, users access a virtual desktop hosted in a data center or cloud. VDI requires reliable, high-bandwidth network connectivity and is sensitive to latency. Network Function Virtualization, or NFV, replaces dedicated hardware network appliances with virtualized instances running on standard servers. Instead of deploying a physical firewall, router, or load balancer, you can deploy virtual versions of these devices. NFV reduces hardware costs, increases flexibility, and enables faster deployment of network services. Infrastructure as code, or IAC, is a practice where network infrastructure is provisioned and managed using code and automation rather than manual configuration. Tools like Ansible, Terraform, and Puppet allow network engineers to define infrastructure in configuration files that can be version controlled, tested, and deployed automatically. IAC reduces human error, enables consistent deployments, and supports rapid scaling. IP version 6 adoption continues to grow as the IP version 4 address space becomes exhausted. IP version 6 uses 128-bit addresses, providing a virtually unlimited number of addresses. While many networks still run dual stack with both IP version 4 and IP version 6, the transition to IP version 6 is ongoing. Network professionals must understand IP version 6 addressing, configuration, and coexistence with IP version 4. Virtual Extensible LAN, or VXLAN, is a network virtualization technology that addresses the scalability limitations of traditional VLANs. While VLANs are limited to 4,096 unique identifiers, VXLAN supports up to 16 million virtual network segments. VXLAN encapsulates Layer 2 frames within Layer 4 UDP packets, allowing Layer 2 networks to extend across Layer 3 boundaries. This is essential in large data center and cloud environments. Let us summarize the key concepts. Modern networks must support IoT, BYOD, ICS, SCADA, voice over IP, video conferencing, edge computing, 5G, VDI, NFV, IAC, IP version 6, and VXLAN. Each of these technologies brings unique requirements for bandwidth, latency, security, and management. As a network professional, understanding these evolving use cases will be critical for your career. Thank you for watching this lesson on Objective 1.8. This completes Domain 1 networking concepts. In the next video, we begin Domain 2 with Objective 2.1 on routing technologies.